the value of a load on a circuit can have a big impact on what you see out of that circuit. So if we look sort of in general at a voltage amplifier, we have a Thevenin source on the voltage, and we have an input resistance on the amplifier, and we have a voltage source, voltage controlled voltage source, and a Thevenin output, and then there's a load. So we have a source voltage, we have a source resistance. These two things, these really represent these two things represent the signal generator, whereas this is the amplifier. And then finally we have the load. But regardless, we have an input resistance, we have a voltage controlled voltage source with the input voltage over here. And we have an output voltage and load voltage and a output voltage, sorry, an output resistance and an output voltage. And we could look at either side of this. We could look at either the sort of the input side or the output side. The thing that I'm interested in is this divider. We have a divider right there. So if we pick either one of these, so I'll draw the kind of a combination of them, really. If we've just got some voltage source, and a load, so we'll call it a voltage source, and we have a source resistance, and we have a load, and then we have an output voltage. So we could just look at that situation. So what is V out? What's the relationship between V out and that source voltage? Well, this is just a divider. It's not, we just have a voltage divider right here, and it just may be drawn in a way that confuses you. But this is a useful way to draw it, but we could certainly draw it like this. The way you might in circuits 1. This would be the same circuit. Let's see, we could have ground down here. Ground, and we could call this VS, and we've got RS and RL. And V out. That's exact. These two things are identical circuits, but maybe you're more comfortable with that representation. Either way, it's fine with me. So how do we find V out? Well, V out is equal to, is just the divider, whichever circuit we look at. So I'll write it up here. V out, because I want you to be comfortable with that one, is just the ratio of RL why does this do this to me sometimes? It's palm recognition, I think it's seeing my palm. RL plus RS times VS. It's just the divider rule. Nothing fancy. And we could also wonder what I out is. I out is flowing like that, or well, the way I've drawn it, I out is flowing through here. So I might have a little sign issue the way I've got it drawn, but anyway, I out is just That's source voltage Vs over Rs plus RL. That's the output current. So if we let Vs equal 1 volt, just because that'll make things easier. Let me go back to black. And we have some values. If we have Rs and RL, and we'd like to know V out and I out. So for Rs is 100 ohms. Those are volts, and those are, let's see, amps. Well, I'll put the units in as I need. 100 ohms, 100 ohms, 100 ohms, 100 ohms. And then for values of RL, we could have the short circuit case, 0. We could have 100 ohms on the load, 100K, big load resistance, or a infinite. So by this, we represent the SC case, the short circuit. And here we have the open circuit. I have no idea why I'm writing so small. I could just zoom in and make it easier to see and easier to write. So in the case of the short circuit case, our output voltage given by this equation, if we've got RL of 0, then we have 0 over 0 plus 100 ohms times Vs. That's got to be, or that is 0. And if we look at this case, they're both the same, 100 ohms each. We'll get 0.5 because 100 over 100 plus 100, so that's 100 over 200, or 1/2 times the value of Vs, which was 1. And if we increase the load resistance to 100K, we get 0.999. Well, that's very close to the full voltage. And if we had open circuit case, that is, if we do the case where the load is just not there, if it's been removed, that would be an open circuit case. And in that case, we'd get 1. Oops. We'd get 1 volt. And how about for the current? Well, that's this other equation, Vs over Rs plus RL. And we would have 10 milliamps. And we'd have 5 milliamps. So the current goes down as that load increases. And we'd have 9.999 microamps. And in the open circuit case, of course, we would have 0 amps. So if you think about that and think about those results a little bit, hopefully maybe there's something that you can kind of glean from there and realize, among other things, that balance between the signal source RS and that load is important. Could do another case here of a large signal source resistance. So we could put 100K here. Let me make this bigger again. We're going to use those same 2 equations. But now we'll go from 0 to 100 to 100K and up to infinity. So the same 4 cases. So we've again got the short circuit case and we've got the open circuit case. Those are sort of the limits. Not sort of, I mean they are, and they're useful to look at. And certainly in the short circuit case, if we have 0 load resistance, then we've got no voltage, right? If this voltage is 0 ohms, so it's a short, then this voltage is equal to ground, and we have 0 ohms. That's an important case. So that's 0 volts. And if I just jump down to the other extreme, the open circuit case, in that case, we have no resistance there in the load. We have just an open circuit. And so in that case, the output voltage equals the input voltage Vs, which is 1 volt. And in between, when they're both the same, 100K and 100K, we'll have a half a volt. And for 100 ohms load resistance with a very large short source resistance, we'd get 0.00. I got enough zeros. It repeats volts, a very small voltage, very close to 0, really. And for the current, of course, with open circuit, we have 0 volts, and the maximum current we'll get is about 10 microamps with 100K there. And if we go to 100 ohms on the load resistance, we'll get 9.99 microamps. And by the time we get to the balanced case, 100K and 100K, we'll have 5 microamps. So it's gradually dropping down to 0. The load and the source resistance play very important roles with respect to each other. The limits may be the same. So these limits may look a lot like these, and these look a lot like these. But what happens in between is very different. And it's important to understand those differences about what the source resistance and what the load resistance are. So when I get this into my open math, I'll try and add some help problems towards the end. But anyway, you can work on this and think about this yourself too.